Okay, so this is where we stopped yesterday. We were talking about limits and discontinuity. This is what your CFA quiz Tuesday is going to cover. Okay, all the the behaviors, the type of discontinuities. In fact, what do we call a vertical asymptote? What kind of discontinuity is that? That's an infinite discontinuity. What do we call a hole? That's a removable discontinuity. Yes, very good. Okay, so let's go ahead and take a look. Now, these are more writing out or verbalizing the ideas. It's the same as the notation we've been using in class. So as x approaches negative infinity, the graph of g approaches, well, it's the same as saying the limit as x approaches negative infinity of g of x equals. Okay, so it's the same as what we've been doing in class. It's just not using the notation. It's actually writing it out. But when you're approaching negative or positive infinity, what do we refer to that as? Remember, this was two words. Okay, what was that, Will? In behavior. That's exactly right. In behavior is if we approach positive or negative infinity. We go to the far left and right sides of the graph, okay, beyond what we see. All right. Now, when you're talking about your end behavior, what is it that you really want to pay particular attention to? The horizontal asymptote. Okay, so Will, help me out. As x approaches negative infinity, the graph of g approaches 1. That is absolutely right, because if we look here visually, we have y equals 1 is my horizontal asymptote. So what's going to happen if I go to positive infinity? It is approaching 1 as well. Now, here's the thing. Does it matter if one direction approaches from above while the other approaches from below? It does not matter. The function will approach that one value, but it will never actually become that value. Okay. Well, what does negative 3 represent to the graph? Okay, that's the hole. That's the removable discontinuity. So we were talking about this yesterday. Sandra, maybe you can help me out with this. As x approaches negative 3, okay, from the left, what is the function g approaching? It is approaching 1/2. Okay, so don't let this confuse you. The function is undefined at this location. Okay, it doesn't exist. But as we approach a value of x, we are still approaching a particular value of y. Okay, so the limit does exist. We are able to say 1/2. In fact, what would happen if I approached it from the other side? Same thing. It's still 1/2, even though that point has disappeared. Okay. In fact, if I were looking at this, if I were to sketch this graph, okay, how would I know there's a hole in the first place if I were just doing this from scratch? Okay. What about a factor? There you go. If you have an item or a group factor that can be canceled. Yes, sir. How did I get that? Well, because we know what the coordinate's going to be, but as we approach x, we're approaching a particular value of y. Now, we won't ever reach it because of the discontinuity, but we're still approaching that value. That's why we say the limit can exist. So one of the things I'm going to do in a couple of weeks is I'm going to show you with tables and decimals, I'm going to show you how we can actually get close to a particular number. Okay, so right now I really can't go into any more detail than that. You kind of just have to trust me on it. Okay. What about as x approaches 1? What does 1 represent here? That's my vertical asymptote, because we've already dealt with the horizontal, right? Okay, that's my infinite discontinuity. Now, if you're analyzing the behavior on either side of a vertical asymptote, remember there's only two options. What are they? Positive or negative infinity. Whatever the graph's behavior on either side, as we get closer to that particular value, the graph's going to decide to get close to it by climbing up or by climbing down. What's happening on the left side? He's deciding to climb down, so he's going to negative infinity. Okay. So what do we notice is happening on the right side? Is he climbing up or climbing down? He's climbing up, so as x approaches 1 from the right, the graph of g approaches positive infinity. Okay. So as I get closer to 1, so maybe, 2, 1.5, 1.1, 1.01, the closer I get to 1, the larger the y values are going to become. They're going to increase without bound. They're going to get closer, but never make contact. Okay. Now the domain both the domain and the range of these particular kinds of graphs will always be infinitely wide and infinitely tall. So you're always going to start with negative infinity. You'll finish with positive infinity. But does anybody believe they have the domain as it should be written for this one? Okay, Connor, what do you think? Negative infinity to negative 3. So the first time we have a problem is with the removable discontinuity, the whole. Okay. Union what? Negative 3 to 1. Okay. So the branch in the middle, we go from the removable discontinuity to the vertical asymptote. Union 1 to infinity. That's exactly right. Okay. And this is the message we want to convey to anybody who happens to look at my work. We want to say that it is infinitely wide, but we're listing those particular values of x for a reason. Some kind of discontinuity exists there. We have to remove it. Okay. Who wants to help me with the range? Okay, Natalia, what do you think?
Negative.
So negative infinity to 1/2. Union 1/2 to 1. Okay. Is she correct? That is perfect. So she did the same thing vertically that we just did horizontally. Now, it is a very thin sliver vertically, but the graph does exist between both discontinuities, between the 1/2 and the 1. Okay, not a lot, but he's going to exist there. Okay. How many people got every one of those correct? Okay, so not bad, not bad. Okay. Anything I can help with? All right. This is what the quiz on Tuesday is going to cover. Limits, discontinuities, the behavior. Okay. All right. Well, let's put that to the side. Okay. I do have another version of this I could probably go ahead and give you on Monday if you're looking for some extra practice. Would you guys want that? Okay, I'll give you an extra one. Okay. I believe I have a second one there. Okay. Let's go to your focus activity. Okay. So here we go. Eli, every time I have something for you to pick up, it'll be right here on the bookshelf when you come in. Okay. All right, so we're still talking about factoring. All right. Now, the first step in factoring, always look for a GCF, and then depending on the number of terms is going to determine the strategy you're going to use. Anybody had the opportunity to look at that factoring map? Okay, it is available. Factoring is going to be a really important skill for us moving forward, and not just with these rational functions. But all three of these guys here, no GCF besides one. Okay, so we're not going to worry about that. Now, again, I want to emphasize, if you have a method that you already feel comfortable with, please feel free to use it. I'm always going to go ahead and use this. My father drives a red Mercedes convertible. Okay, so tell me what the steps mean. What's that M? Multiply. The F. Factor, then we divide, reduce. The second M is to move the values, and then we check our answers. Okay? So what does it mean, the first M, multiply? What would I multiply in this trinomial? There you go. You multiply the leading coefficient by the constant. So 9 times -8, -72. Now, that tells me I'm going to have a negative and a positive factor. This right here is the most important step. Okay, this is also the most difficult. All I need to do are find two numbers that will multiply to give me -72, but they also have to add to give me 6. Positive 12, -6. Perfect. There you go. If you can find yourself those two factors, guaranteed you've got this right. The rest of it's only going to take seconds. Okay. Well, you told me divide. What would I divide by?
8.
Okay, so I'm going to divide by 9. We always divide by the leading coefficient. Reduce, -6/9. Okay, -2/3. 12/9 would be 4/3. Now, moving those values gives me my group factors, okay, the factored form of the expression. Would this be -2y plus 3 or 3y plus or minus 2? There you go. You always start in the denominator and you work your way up. So that would be 3y minus 2 times what? 3y plus 4. There we go. Okay. All right. Is there anybody who already had all three of these factored before we even started? Okay, so a few. Very good. Very good. All right. Let me catch up to you. Number 2, 6x squared minus 7x minus 20. Okay, I want to break this apart. What do I multiply? 6 times negative 20, so that gives me a negative 120. Negative and a positive. Okay. So I need two numbers that will multiply to give me negative 120, but add to give me negative 7. Okay, so I'm looking at the folks who have already factored it. Negative 15, positive 8. Okay, there you go. And there's really no exact way to go ahead and immediately find those factors. Sometimes, especially if you have a large product, the best bet is just start dividing and eliminating pairs. Okay, just try to figure out which pair will work. All right, so now what? I got my factors. Divide by 6. That's my leading coefficient here. So divide by 6. Simplify will reduce. Negative 15, 6. Negative what? Negative 5 halves. Okay. What about 8, 6? 4 thirds. Okay. And what would my two groups be? 2x minus 5 times 3x plus 4. There you go. Okay, would anybody like to check? All right, but you'll notice once you start to get the idea, this process does go faster. All right, it went slow in the beginning because I got to teach you how to do it. Okay, let's try this last one. Let's see here. So we already know the steps. I'm going to multiply 5 times negative 27. Xavion, what's that? 5 times negative 27. Negative 135. Okay. So I'm looking for my two factors that will also add to give me a negative 42. Prasansa, do you have those? No?
45 and 3.
That's exactly right. 45 and 3, but which one's which?
Negative 45.
Negative 45, positive 3. Remember, signs are very, very important. Okay? The placement does matter. All right. Now what? Okay, we're going to divide by 5. Okay. 3/5 will not reduce. What if it does divide evenly? Remember, leave it over 1. Leave it as a fraction because we need those values to create my binomials. So this is negative 9 over 1. What are my two groups? 5a plus 3. And then 1a minus 9. Perfect. There we go. Okay. Now, nobody said it in this class, but inevitably in the other classes so far, somebody's always said 5x plus 3 and x minus 9. Would that make a difference? Okay. Technically, I'm going to say no. A variable is just a letter that represents an unknown value, right? So if you happen to go ahead and use a different variable, I'm not going to count off for that. Because some people just automatically go back to default. We write everything in terms of x. Okay, so if you said 5x plus 3, x minus 9, I'm not going to fault you for that. I always try to stick with the same variable, but even I'm going to do that occasionally. Okay, all right. Now, because we have a new student, help us out. What do we do with these focus activities? We keep them safe. Keep them in a folder, keep them in a binder, someplace safe, because at some point I'm going to ask for you to turn those in. Okay, that's going to be a quiz grade. Should be a guaranteed quiz grade. Okay. Here's what we're going to go ahead and do. I'm going to start giving you some instructions about the quiz we're about to take. I've got 10:20. We get out of here at 52. We got plenty of time for this. First off, take out a sheet of paper, please. Okay. What I'm going to need you to write at the top is your name, and then you're going to title this Parent Functions and Transformations. Okay. Okay, so take out a sheet of paper, put your name on it, parent functions, and transformations. We are going to be inputting our answers into the system using a Chromebook. If you have your own laptop and you want to use it, please feel free. Okay, but technology is not always 100% effective or reliable. Let's go ahead and say that's probably a better word. So just in case there is a problem with the answers online, I have a hard copy to go ahead and grade. So there's only 5 multiple choice questions. Okay, so I need your name, parent functions, and transformations. All right, in fact, let me go ahead